Today we're going to move on to matrix multiplication, which is actually a lot harder than what we've been doing with adding subtracting matrices, and it's done in a really weird way. So it's going to take a little bit to understand how to do it, but we'll get through it, and hopefully it won't be too bad after we do a couple examples. So how do you want to multiply matrices together? So we did add and subtract, and we did multiply by a number, but now we're going to multiply them together and see what happens. So first thing we have to look at is the dimensions. So matrix multiplication, if you have a matrix A and it has an m by n matrix, so say like a 3 by 4, and B is an n by q matrix, see how the two n's match? So this would be like a 4 by 7, something like that. Then the matrix product, when you multiply them together, A times B, is an m by q matrix. So what does all that mean? That means we're looking for something very specific when we look at the dimensions of the two matrices to see if we can actually multiply them. So if we go down this little example down here, we'll do some highlighting, I think. We have two matrices down here. One is a 2 by 2, and the other one is a 2 by 3. What we are looking for is we need to look at the two middle numbers here. This would be the columns of the first matrix and the rows of the second matrix. If they are equal to each other, then you are able to multiply them together. That's all it means. If they're the same, we can multiply them together. If they are different, then you cannot do anything else with multiplication. We could just say there's no answer. So since in this case they are the same thing, we can put them together. So if that happens and they're the same, then what you do is you take the outside numbers of the dimension. So we have a 2 by 2 and a 2 by 3. If they're the same, we take the 2, we take the 3, we put them together, and that gives you your answer when you do multiply them together as a dimension. So we take the 2, we take the 3. That gives us a 2 by 3 out, as you can see, 2 rows, 3 columns, and that gives you the dimensions of the product. Now, we're not even talking about how you multiply them together yet. We're just talking about can you multiply them, and if you do, what do you get out as a dimension? So when we cross a 2 by 2 with the 2 by 3, we get out a 2 by 3. That's what we're looking at. If you go to the second example here, so I'm going to do a dividing line. So it says up top, these matrices can be multiplied. We just talked about that. These ones cannot be multiplied. Why is that? If you have a 2 by 3 and a 2 by 2, the two middle numbers do not equal. And that's pretty important. This is the biggest thing. If you look at these two numbers, a 3 and a 2, they are not equal. There will be no product. It's simple as that. There's no answer. If you're trying to put these two together, it's not possible. Not possible. So that's the first order of things. Before we even try to multiply them together, we have to see if we can multiply them together. So we're just going to do some examples, seeing if we can multiply two matrices together. So example 1, determine if the matrices can be multiplied. If yes, find the dimensions of the product and what they will be. So for the first example, we have a 1 by 2, right? You have to identify the matrices. And the second one is a 2 by 1. Can you multiply them together? Yes, we can. These two numbers are the same, 2 and 2. So yes, we can. What is the dimension of the product? So if we were to multiply these together, what's the dimension? Remember, that always comes from the outside numbers, 1 and 1. So in this case, it would be a 1 by 1. Okay, move on to the next one. This dimension would be a 2 by 3. And we're going to cross that with another 2 by 3. So in this case, if we look at them, they're the same dimensions, but the two middle numbers do not equal. We have a 3 and we have a 2. Not the same. So can they be multiplied together? Absolutely not. What would be the dimension of the product? Well, that's kind of a hard question to answer because you can't put them together. So there is no dimension of the product. I'm just going to write none. Not possible. Which is good because then we actually can't multiply them together. And there's no reason to try. And for the last example, and you also notice that these are the exact same dimensions, a 2 by 3 and a 2 by 3. even though they have the same dimensions, you can't put them together. It all depends on what those two middle numbers are. And the last one here, we have another 2 by 3, but we're going to multiply that by a 3 by 2. So is that allowed? Let's look at the two middle numbers. We have 3 and 3. They can be multiplied together, yes. What is the dimension of their product? Again, that's the outside numbers, like always. Only if the two middle matches, then the answer of a product would be the outside numbers, a 2 by 2. Once we know this and figure this part out, then we can slowly move into how do you multiply them together. And that's kind of like the harder part. So we have a bunch of fill in the blanks here. The top part here just kind of goes over what we just talked about, the criteria for multiplying matrices. So what do we have to look at? We have to look at dimensions. Then we have to see if those two middle numbers are the same. If they are, then we can multiply them. So we have to look at the dimensions to determine if you're able to multiply. So what we're really looking at, those two middle numbers, we're looking at the columns of the first matrix. We're seeing if that equals the rows of the second matrix. I already pointed that out before. We had a 2 by 3 and I think a 3 by 2. We're looking at the columns of the first and the rows of the second. Because remember, it goes rows, columns, rows, columns. So down here in this box, it's not going to make much sense when we fill this in. When we do the actual problem, it'll make a little bit more sense. But then we're going to refer to the first matrix. Pretend this is like the first matrix. They're going to refer to that as the row matrix. The second matrix is the column matrix. Because what we're going to do is we're going to look at the first matrix and only look at the rows. In the second matrix, we're only going to look at the columns. That's why they call them the row matrix and the column matrix. So how do you actually multiply them together? What we're going to do is we're going to take the first number, the first element, in the first row matrix. So if, for example, we're going to go across the row here, -1, 10, 3, and we're going to multiply those numbers by the first element in the column matrix. So I go back here, we're going to do -1, 2, 10, 4, 3, -5. You go across the row, down the column. So that was just the first element. Then you do it to the second element, like I already showed you. Do it to the second number of the row matrix, the second number of the column matrix. And you continue doing this, continue multiplying together until you get to the end. Until you get to the end of the row or column. So like I said, you're going to go -1, 2, 10, 4, 3, -5. Multiply them together. So you multiply -1 and 2, and after we do these, we're actually going to add each product together. That's step 2. So we're going to do -1, 2, plus 10 times 4, plus 3 times -5, and that will give us an answer. And we keep doing this. We repeat steps, the first two steps, until we do it to all the rows and all the columns, and they're all multiplied together. So we're going to try this first with letters, and then we'll apply it to numbers and see what happens. Okay. So we have two matrices, A times B, that we're going to multiply together. They just replace the A and replace the B with the matrix. Let's look at the dimensions because you always have to do that first. 2 by 2 and another 2 by 2. Do the middle numbers match? Of course. And what are we going to get out? A 2 by 2. So I'm just going to put blanks spots here. 1, 2, 3, 4. And I'm also going to label the rows and columns. Let's get rid of some of the stuff around here. So this one has 1, 2 rows. This one has 1, 2 columns. The first matrix, all we care about is the rows. The second matrix, all we care about is the columns. That's how it always is. And on here, we have 1, 2 rows and 1, 2 columns. All right, so how do we do this? If we want to get the first blank spot here, you ask yourself, what row and what column are you in? We're in the first row, and we're in the first column. So we go over here to our matrix. We go to our row matrix, which is the first one. We're in the first row, which is A and B. And we're in the first column of the second matrix, that's E and G. So as we go across the row, we're going to multiply the numbers as we go down the column. So it goes A times E plus B times G. You go across and then down. Let that sink in for a little bit. Get rid of all this. So what happens if we just change to another position? How does that change things? If I go over to the next column, right, now I'm in the second column, but I'm still in the first row. So how does that match over here? First row still using A and B, but now I'm in the second column, so now I'm using F and H. So this is, again, go across and down, same time. So this would be A times F, that's the ugly F there, plus B times H. So you follow that? The first row we just used as we went down the second column. All right, so what if we jump down here to this blank spot? So now we're going back to the first column, but we are in the second row. So let's highlight it over here. Second row, which means we're going to use C and D going across. But now we're going back to the first column, back to E and G. So to multiply these together, maybe you can write that out, see if it's right. This would be C times E plus D times G. That's a CE, if you can read that. CEDG. We only have one more blank spot left. Try red. How about this one here? So where are we at? You got to look at the location. Second row, second column. Use that over here. Second row, C and D. Second column, F and H. As you go across, go down. So we will do C times F plus D times H. And after we do the multiplication and addition, we will eventually get a 2 by 2 matrix with just 4 numbers. So it came out to be a 2 by 2. So let's try it with some numbers. First one is going to kind of break it down and make sure you remember to do the dimensions first, check to see if you can multiply, and if everything works, then you can multiply. So what are the dimensions of each matrix? So I'm just going to do a little arrow here. This is a 1 by 2, and this one here is a 2 by 1. So do the numbers match in the middle? Because they have to in order for them to be able to multiply together. So they do match. So do the inside numbers match? Yes. That means we can multiply. If yes, when we multiply them, what are the dimensions of the product? Look at the outside numbers. We're going to get a 1 by 1. It's pretty easy. If not, so if these numbers did not match, what happens? Well, we would say the answer does not exist. You cannot multiply them together. So since we did say yes, and we know we're going to get a 1 by 1 out, we're going to multiply them out and see what we get. So I'm going to copy it down, 1, 2, and a 3, 4. How do we multiply them together? We only have one blank spot. This is a 1 by 1. One row, one column. Over here, we only have one row and one column. So to get this blank spot here, we go across the row, across the first column, or down the first column. So first row means we're going to use 1 and 2. First column, we're going to use 3 and 4. So we're going to do 1 times 3 plus 2 times 4. Remember, we go across and then down. So our answer will be 8 plus 3, 11. And this is a 1 by 1. One row, one column. Okay, we have a couple left. Multiply the following matrices if possible. So first one here, we have a 1 by 3 and a 3 by 1. Always do this part first. Hey, they're the same. So we're going to get out a 1 by 1 again. This is almost the same as the last one. The only difference is we have extra numbers going across and up and down. So we have one row, we have one column. So in order to do this, we're going to do this blank spot will give us the first row as we go down the first column. And so all the numbers should match up till we get to the end. We do 1 times 4 plus 2 times 5 plus 3 times 6. If I can squeeze it in there. All of that being multiplied together and then added will be your final answer. So what is this? 10, 18, 28 plus 2, 32. 28 plus 4, 32. That's it. B, we have a 2 by 3 and a 3 by 2. 3 by 2, yep. These are the same, so we're going to get a 2 by 2. 1, 2, 3, 4. Remember, the outside numbers tell you what we're going to get out, so we can multiply these together. First blank spot, this one here. Again, I like to label these. We have 1, 2 rows. We have 2 columns. This also has 2 rows. This one has 2 columns. We're going to go across the first row, down the first column, and multiply them together. So this would be 3 times 1 plus 8 times 0 plus 2 times negative 2. The next one, change it up a little bit. We're moving on to the second column, first row still, second column. So we're going to use these new numbers with the numbers we just used on the last one. So this would be 3 times 6 plus 8 times 4 plus 2 times negative 1. All right, the one down below, we're going to go across the second row down the first column. So it'll be negative 2 times. Hopefully you're catching on. This can go a little faster here. Negative 2 times 1 plus, oops, I already did plus. Plus 1 times 0 plus negative 8 times negative 2. If I can get that, squeeze that in there. And the last one, second row, second column, will be negative 2 times 6 plus 1 times 4 plus negative 8 times negative 1. Do all that math, and we'll get 4 numbers to be our 2 by 2. All right, let's see what we got. 3 plus 0 plus a negative 4. It's negative 1, I think. You can double check. You can use your calculator to get these. Then we have 18 plus 32. That's 50. And then this is minus 2, so 48. The bottom left here would be negative 2 plus 0, and then plus 16. It's positive 16. So that'd be 14. And the last one, this is negative 12 plus 4, negative 8. And then this would be a positive 8, so that's 0. And there's your 2 by 2. All right, we have one more to do, and then we'll do a word problem and be done. I'm going to go a little faster, though. This is a 3 by 2 and a 2 by 3. So we're going to get out a big old 3 by 3. These two numbers match. So we do 1, 2, 3, 1, 2, 3, 1, 2, 3. All right, first row, first column would be just these two numbers going across and these two going down. So this would be 1 times 3 plus 6 times negative 2. All right, the next one we're going to go across. Now we're going to do the second column. Repeat the first row, though. So 1 times 8 plus 6 times 1. Next column, move over. 1 times 2 plus 6 times negative 8. Going down to the next row, so now we're using this with the first column. 0 times 3 plus 4 times negative 2. Staying with the same row, next column, 0 times 8 plus 4 times 1. Then we have 0 times 2 plus 4 times negative 8. Bottom row, first column, negative 2 times 3 plus negative 1 times negative 2. I don't have enough room for this. Then we have negative 2 times 8 plus negative 1 times 1. And the last one is negative 2 times 2 plus negative 1 times negative 8. 1, 2, 3, 1, 2, 3, 1, 2, 3. Probably the biggest one we're going to do. It's pretty big. Figured all these numbers. Let's quickly do that. So we have 3, and then I think that's negative 12. So negative 9. Going across here, we have 8 plus 6, which is 14. 2 minus, this would be a negative 48, so negative 46. Next row, that's 0, and that's negative 8. This would be 4, 0, and I think that's, oh man, negative 32, I think. Because 0 times 2. In the bottom row, we have negative 6 and a positive 2, so negative 4. Negative 16 and positive 1, negative 15. Hope I'm doing that right. Oh, wait. Only one of them is negative. This is negative 17, I believe. And the last one would be negative 4 and positive 8, so 4. And there you go, 3 by 3, which is the hardest one we did. All right, last problem. We're going to read through example 4, and it seems like it's a lot, but it's actually not that bad. So suppose the Forensics Club F, the Jazz Band J, and the volleyball team V are each holding pizza parties and are each ordering different quantities of cheese, mushroom, and garbage pizzas, and want to compare prices at 2 different pizzerias, Lorenzo's and Billy's. Below are the matrices describing the above situations. So we have Lorenzo's prices and Billy's prices of how much it costs for cheese, mushroom, and garbage pizzas. And then we have how many pizzas are going to get of cheese, mushroom, garbage from Forensics, Jazz Band, and volleyball team. So that's what it says in the last sentence. One matrix contains the prices in dollars for each type of pizza at the 2 pizzerias, and the second matrix contains the number of each type of pizza ordered by each club. All right, so it's just all in, a nice stored amount of data in these 2 matrices. Which, by the way, I might as well just do the dimensions. We have a 2 by 3 and a 3 by 3. So if we wanted to multiply these together, we would be able to, but it's not going to ask us to do that here. It says, write a single expression giving the total price for pizzas at Lorenzo's for the Forensics Club, and we'll evaluate it. So we're only looking at one specific combination. Instead of multiplying all this stuff together, we're looking for Lorenzo's. So Lorenzo's prices, that row, and we're going to compare that to the Forensics Club and how much they're going to get, how many pizzas. So Forensics Club is F. So they only want us to do the multiplication with that row, first row, and first column. And that will give us how much they're going to pay if they got the pizzas from Lorenzo's. So how do we do it? Across the row, down the column, no different. So we have $12 for a cheese pizza, and they ordered 4 cheese pizzas. So we multiply them together and keep going. Plus $15 for a mushroom times how many they got? 3. Plus $20 for garbage, and they got 2. So it's interesting that as you do matrix multiplication, it actually works out to find the total price of the pizzas. This would be if the Forensics Club chose Lorenzo's. You could do the same thing to find Billy's. You just go across this row instead. Go down the same column. So all the combinations are here. You just have to figure out what you get. So we multiply these together. We're going to get 48 plus 45 plus 40. So that is 120 plus 13, 133 is how much it would cost for the Forensics Club. And that's it. So if you're going to turn this in, we're going to turn it in and do the entire notes. You're going to finish off all the huddle. There's 1, 2, 3, 4, 5, 6. 6 problems. And then go back and do the rest of the warm-up. 1, 2, it's like 3 or 4 problems there. That's it. And then you'll turn those in. Every single page and every single problem, including the ones we did together.